All right, folks, 4.2, inverse functions. So inverse, right, is kind of the opposite of what we started with. But when we talk about it with functions, we're talking about simply switching the x and the y values. So what I mean is if I gave you a table of values, x and y, let's say we had a value of like 0, 1, 2, 3, and my y values were 5, 8, 11, and 15, right? Let's say we had those. So literally they're saying, well, what's the inverse function? It is literally switching these around. So now what we call the inverse of x, which we actually write like this, inverse of x, so then the inverse of y, would literally be now 5, 8, 11, 15, and this would now be 0, 1, 2, and 3. It's literally switching. So let's talk real quickly about how we do function notation. If I had a function of x, remember which is what we call y, that's the normal function, then the notation for inverse looks like this. Inverse of the function. So there's some notation that you're just going to want to be familiar with, right? Is it the function or is it the inverse of the function, right? So here's what I want you to know. Simply switch the x and y values and then redo, okay? So let's talk about this. Let's do the examples. Graph the relation and connect the points, then graph the inverse. Identify the domain and range of each of these, okay? So let's just talk real quick. Whoa. Number 2. So number 2, let's just do the basic graph, and I will do this with 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's take each of these points. So let's take the point 1, 1, graph it. Let's take the point 2, 2, graph it. Let's take the point 3, 4, graph it. Let's take the point 4, 8, and graph that. All right, so let's just connect these, and we'll just do just these points here, right? So we're not going to put arrows at the end of this because we're not doing an entire equation. I'm literally just graphing those 4 points, right? So the 2, 2, the 3, 4, and the 4, 8. All right, now we know the inverse. The inverse means that you're going to switch those values. So the new x and the new y, right? So it's going to be 1, 1, 2, 2, 4, 3, and 8, 4. See how I switched them, right? Everything that used to be on the bottom is now on the top, is now on the x. So let's plot these points. I'm going to do this in a different color, okay? So then I got 1, 1, 2, 2. Then I got 4, 3, and then I got 8. That's 4, 5, 6, 7, 8, 4. And let's graph those ones. Okay, there it is. All right, so inverse function, literally switching the x and y's and regraphing with whatever points you have. Here's another thing that you're going to take note of, right? If I were to put this line, you know what this line is right here that goes through here? This line is called y equals x. This is going to be a good function to know. Y equals x. It acts as a mirror, right, on this. So if I were to draw something on this side, like the red, then it gets reflected. Remember that geometry term, reflected, over here across y equals x. So this is always the inverse reflection line. Reflection line. The inverse reflection line, y equals x. So you know why? Because check it out. You can swap them and get the inverse. You can swap them back and get back, right? So y equals x, we're just saying we have switched things up. So there's the simple way, literally just switch and replot. And then there's the the reflection way, right? If we want to talk geometry, we can do reflection. So that's what it would look like right there, right? So I could do the other graph, but I think we're just going to stick out with that. Just know that we could always plot the points, switch the x and y's, replot the points, and you got your inverse. Or if you are more artistic in style, do a reflection across y equals x. Perfect. Okay, so that's graphing. All right, let's talk about writing functions. Writing functions. We want to use inverse operations to write the inverse of the function listed. Okay, so what did we talk about we're doing? Well, go back to its simple form. First thing I'm going to do, I'm going to reclaim f of x as y. So y equals x plus 3. Our main job then is to simply switch x and y. So watch this. X equals y plus 3, right? So step 1, switch x and y. Step 2, resolve for y. Okay, so we're going to resolve for y. That's going to be easy. Subtract 3 from both sides. And now we're going to get x minus 3 equals y. Or, let's just turn it back around. Y equals x minus 3. And then put the f of x back on. So instead of y, now we're going to put f of x, except now since we've done something to it called an inverse, we want to use that notation. And we got it. We're done. There is the inverse of the original function. Right? The inverse of the original function right there. All right, let's try the next one. Let me do the same idea of the next one. I want to first take the f of x. I want to think of it as y equals 4x. Simply switch the x and y and then solve. Resolve for y. So then I get x over 4 equals y, or I like to always just write it y equals x over 4. Okay, let's put it back into its notation. Fx inverse is equal to x over 4. This is the inverse, this is the original, right? So that is how we do this. Okay, let's talk about this one right here. Let's do another one. Just quick check. F of x, I want to write it with the y just to get notation, y over 2. Swap x and y. X equals y over 2. Whoa, I should keep my color coding going. Y over 2. All right, I want to get y solved for itself again, multiply by 2 on both sides. So then I get 2x equals y, or y equals 2x. And then let's just take it back to its function notation. There's the inverse of the original function. Now here's something that you should always be able to do. This is how you can check. Does it work? So I'll do it for each one. So let me think about number 4 over here. So you should be able to take the inverse function and literally plug it in for the x and see what happens when we do that, right? Because the inverse function plugged into the function should leave you just with x, right? So check this out. So if I took number 4, if I took f of x is equal to, instead of x, I'm going to replace x minus 3 plus 3, work it out, equals x minus 3 plus 3, those cancel, equals x. And if it equals only x, you know that you've got the actual inverse. So let's try the next one. F of x equals, instead of the x, I'm going to put 4. I'm going to say what x equals, right? What the inverse equals. We're just going to plug the inverse in for the x value. All right, let's see. Those are going to cancel. We're going to equal x. All right, number 6. Let's try this one. F of x equals, instead of the x, I'm going to put what the whole inverse equals, 2x over 2. Those cancel, equals x, check, right? Those are just a check, right? So a check that the if you plug the inverse in for the x of the original equation, it will equal x. All right, let's move on to a word problem. Okay, so here's what I want you to know. When it is a word problem, we do not, okay, let's do this. Do not switch the variables. It's kind of funny that way, but because Celsius is named for an exact temperature and Fahrenheit is named for an exact temperature, we just don't switch the variables. But you still do the solve for the other variable like you would after you did the switch, okay? So this one, the formula Celsius equals 5/9 Fahrenheit minus 32 gives degrees Celsius as a function of degrees Fahrenheit. Find the inverse of this function to convert. So literally when they say find the inverse of a word problem, we are simply going to just solve as if they've already been flopped for the f, okay? So here we go. How do we do that? Well, we have some options available to us. We could distribute the 5/9 across, or we could just get rid of the 5/9. How do we get rid of a fraction? Well, this fraction is being multiplied to the whole thing. So let's just multiply by its inverse, and that will undo the fraction. But we got to multiply the other side by that. Okay, so now we have 9/5 Celsius is equal to, now we've undone the parentheses. So it looks like, okay, what's our next step? We need to get rid of that negative 32 there. How do we do that? We add 32. Add 32 to the other side. Now we got 9/5 Celsius plus 32 equals the Fahrenheit temperature. Well, we're officially done here, people, with the inversing the function, which just means solving for the other variable. In this case, in a word problem, do not switch x and y, just solve as they are, because they're probably not going to give you x and y, they're just going to go with these. They have very specific meanings, the Celsius and the Fahrenheit, so we don't want to switch them out. Okay, so then the next part of the question, if we look up here, 16 degrees Celsius, what is it in Fahrenheit? 16 degrees Celsius means let's just plug that thing in. So here we go. 9/5 times 16 plus 32 equals our Fahrenheit. If I do that, it's 28.8 plus 32 equals our Fahrenheit. Let me do that real quick. So then you get 60.8 degrees in Fahrenheit. So if somebody says, hey, it's 16 degrees Celsius, you would say, well, you know what? That converts to 60.8 degrees Fahrenheit. Right, so there's the conversion. That's what we're going to be doing. So think inverse. Simply switch x and y and then solve just for the other variable when it comes to word problems. So write this down for yourself. Do not switch the variable for word problems.